My name is GODALEX Okori. I'll be presenting on the topic real-world analytics using aggregation function for data analysis. Okay, for this assessment, the set of data that have been provided for us to use to analyze is the red wine quality set of data. The next slide. The basic requirement for this assessment, we are to analyze the given red wine set of data and predict the wine quality using the following steps, which includes visualizing the data, then we transform the data. After doing this, we build a model and compare results. From the results gotten, we'll now use the best model for our prediction. Next slide. Yeah, the data visualization, I use the GGG plot tool where we have the scatter plots, histogram, and also the curling. Then for the codes, the various codes are all showed here, as we can see. These are the various codes used to extract the scatter plots, then that of the histogram as well, and that of curling. Then on the next page, here, we've seen the scatter plots. Basic insights we can deduce from here. We can find clearly that there's a fairly increase in the rank with increase in the alcohol. Then on the scatter overall as a whole, I can't conclude as of now. So next slide. For the histogram plot, we can see clearly that the citric acid is positively Q. Chloride is also positively Q. Total sulfur is positive skew. Then clearly the pH is almost normal, as we can see here. It's almost normal. Alcohol is positive, while the Y variable here is slightly positive. Next slide. In transforming the data, I selected the variables for analysis: alcohol, citric acid, the total sulfur dioxide, and a pH. However, I didn't pick the chloride because it shows very similar properties for all the qualities. Then the variable of interest here, which is the Y. Next slide. Okay, in transforming the selection, this is the code for this, which I've extracted here clearly for the essence of this assessment, as we can see clearly here. Next slide. Okay, these are my various codes, but I have coded it this way, whereby you can see that I stated here clearly that if Qness value is less than minus 0.3, and the p-square method will be applied. Then if the Qness value is between minus 0.3 and 0.3, no transformation will be applied, and so on. Next slide. In standardization and normalization, I have put mini and max methods and the z-score methods to standardize the data so that it gives reliable results during our prediction. These are the codes used here. Now, in building the model and investigating further, model use according to the tax, the weighted arithmetic mean, the weighted power mean with p value equals to 0.5, sorry. Then the weighted power means with p value equals to 2. the other weighted averaging function over. Here are the quotes extract here as well too. Now, here are our results. On the inside here, you can see that characteristic of a good model. The RME shows clearly here that it should be low. Then the ABF0 should be low too. Pearson correlation should close to 1. The Spearman correlation also is close to 1 as well. Next slide. On the weighted comparison, we can see these are the various critical values. Importance of each variables. In general, alcohol content has played a major role in determining the quality of the wine. Think about 70% in the average. Next on the line there is the citric acid content. Determine the quality of about 20%. Whereas the sulfur content and pH both together play a minimal role of just less than about 10% to this. Now, a best fitting model and chosen model based on the values of error, correlation, and weighted arithmetic mean and the weight means power perform very similarly. Now, keeping overfitting in mind, after all this analysis, then I choose the simplest, which is more generally, that is the model of the weighted arithmetic mean 1 for this. The next slide. Using 1 for prediction, applying the same transformation on the new inputs. You can see that the citric acid square rooted, sulfur log, pH none, alcohol log. These are the quotes I used there. Next slide. Standardizing the new input same as before, using the minimax and z-score being applied. These are the quotes here. Applying weights and prediction, the value using the 1 as well. So now, here is the quote. Reversing the standardization and transformation. F-score is reversed as it applies to the last. Next is the min-max is also reversed. Finally, the variable of interest, which is the y, is reversed using exponential of y. Next slide. Applying the reversed, here are the quotes as well. Extracts. And move further. Predicted results stored the quote. You can see that the quality of wine predicted for the new input is 5. Overall insight. The quality of wine predicted by my model is 5. And I'm certain it is reasonable enough because the weight of alcohol and citric acid play a major role in the wine quality according to the analysis discussed earlier. So comparing the scatter plots of citric acid and alcohol, the prediction value agrees with the overall distribution. So now our new inputs for citric, total sulfur, and pH and alcohol will now be 0.9, 38, 2.53, and 7.1. Next slide. Best condition for higher quality wine. Yeah, I'm optimistic that we will get a higher wine quality by increasing alcohol and citric acid content. Knowing fully well that they determine the quality of about 90% according to my analysis so far carried. Implication, flexibility in aggregation, simple interpretation, and robustness to outlier. Then our limitation, as far as this is concerned, we have sensitivity to weight choice. Then our assumption of linearity. I think I will share my link for this video on this slide. Thank you. Thank you.